Hi students, welcome to Sunil's tutorial. I am Sunil Milwani and today we will be doing the numericals of electrons and photons. Stay down people. An electron is accelerated through a potential difference. An electron is accelerated through a potential difference of 2000 volts. An electron is accelerated through a potential difference of 2000 volts in a magnetic field of 0.2 Webers per meter square. In a magnetic field of 0.2 Webers per meter square. Calculate the velocity of the electron and the radius of the path if calculate the velocity of the electron and the radius of the path if the mass of electron is 9.1 into 10 raised to minus 31 kgs and the charge on electron is 1.6 into 10 raised to minus 19 coulombs. Now, kinetic energy is half mv square, right? So I can say that you consider this v this way. Now, kinetic energy is also equal to charge on the electron into potential difference. Thus, I can say that v square, half mv square. Okay. I can therefore say that half mv square is equal to EV. So in which case I can say that V square is EV 2EV upon M. So I can therefore say V is equal to square root of 2EV upon M. So I know E, V and M. So I should be able to find out the velocity of electron. Once I have this, then I can say that they have asked you to find out the velocity of the electron and the radius of the path. I can say strength of the magnetic field is BE. Strength of the magnetic field into charge on the electron is going to provide the necessary centripetal force, that is going to be nothing but mv by r. Actually this is BeV and centripetal force is mv square by r. I have cancelled the V and V and that's how I got this, right? Therefore, I can say that radius is equal to mv upon dE. Right? The answer for this sum should be velocity should be equal to 2.652 into 10 raised to 7 meters per second. And radius is equal to 7.542 into 10 raised to minus 4 meters. Take on next one please. A charged oil drop is suspended. A charged oil drop is suspended in an electric field if the charge on the drop is 4.8 into 10 raised to minus 12 coulombs. If the charge on the drop is 4.8 into 10 raised to minus 12 coulombs and the mass of the drop is 4.8 into 10 raised to minus 8 kgs. Find the strength of the electric field. Find the strength of the electric field. Now guys, since the drop is freely suspended, therefore the upward force should be equal to the downward force, right? Now the upward force is going to be provided by charge into the strength of the electric field. Downward force is going to be provided by mg, right? In that case, I can therefore say that strength of the electric field is mg upon q, right? The answer for this sum should be equal to 9.8 into 10 raised to 4 newtons per coulomb. Next, take on next one please. What voltage is required? What voltage is required to balance an oil drop? What voltage is required to balance an oil drop carrying a charge of 10 electrons located between plates which are 6 millimeters apart, if the mass of the drop is 3 into 10 raised to minus 15 kgs and charge on electron is 1.6 into 10 raised to minus 19 coulombs. Same like the previous sum, I can say since the drop is freely suspended, the upward force should be equal to the downward force. I can say that upward force should be equal to downward force. Upward force is provided by the electric field, the charge of the electron and the strength of the electric field. Downward force is provided by mg, right? Now they have asked you to find out, guys. I can therefore say that E is equal to mg upon q. They have asked you to find out what voltage would be required, right? Now E is also given by the formula. Strength of the electric field is potential difference per unit distance. Therefore I can say that V upon D is mg upon q. Therefore potential difference will be mgd upon q, right? The answer for this should be 110.25 volts. Next, take down next one please. In Millikan's oil drop experiment, the mass of the drop is 1.6 into 10 raised to minus 14 kgs. The mass of the drop is 1.6 into 10 raised to minus 14 kgs. Is separated by a distance of the plates. Is placed between plates separated by a distance. Is placed between plates separated by a distance of 3 millimeters when a potential difference of 1500 volts is applied to it. When a potential difference of 1500 volts is applied to it. Calculate the charge on the drop. Millikan's oil drop experiment, since the charge is freely suspended, since the drop is freely suspended, therefore I can say that upward force should be equal to downward force. upward force is nothing but QE, downward force is mg, right? They've asked you to find out the charge. Now Q, E, electric field, is nothing but potential difference per unit distance. Therefore I can say Q is equal to mgd upon V. I know M, I know D, V, G is constant. I'll come to know the charge. The answer for this sum should be 3.136 into 10 raised to minus 19 coulombs. Next, what electric field can support a water droplet? What electric field can support a water droplet 1 into 10 raised to minus 6 meters in diameter, 1 into 10 raised to minus 6 meters in diameter, carrying a charge of 1.6 into 10 raised to minus 19 coulombs. If the mass of the drop, no, mass of the drop is not given to you. That's it. That's all that's given to you. Okay. Now, I can say that diameter is given to me, so I can find out the radius. Radius is nothing but diameter upon 2. So radius is going to be equal to 1 into 10 raised to minus 6 upon 2 meters, which is nothing but 0.5 into 10 raised to minus 6 meters. Now, we know that density is nothing but mass upon volume. Therefore, I can say that mass is equal to density into volume, right? Density into volume. Volume of water drop. Water drop is in the form of a sphere. Volume of water drop is 4 by 3 pi r cube. Volume of a sphere is 4 by 3 pi r cube. Now, density of water in MKS system, in SI system, is nothing but 1000 kgs per meter cube. Density I know, 4 by 3 I know, pi r cube I know. So I come to know the mass of water drop. Now, since the water drop is freely suspended, since the water drop is freely suspended, therefore I can say that upward force is going to be equal to downward force. Upward force is QE, downward force is mg, right? They have asked you to find out what electric field. They have asked you to find out E. Mass. Mass you just found out as rho 4 by 3 pi r cube G upon Q. You will get your strength of the electric field. The answer for this should be 3.208 into 10 raised to 4 volts per meter. Next, take our next sum please. Right. An oil drop of diameter, 10 to the power of minus 5 centimeters, an oil drop of diameter 10 to the power of minus 5 centimeters carries a charge of 2 electrons, is suspended between plates, 10 millimeters apart, is suspended between plates 10 millimeters apart, If density of oil is 1.8 grams per centimeter cube, if density of oil is 1.8 grams per centimeter cube, calculate the potential difference required. Now first of all, let's convert this. 1.8, since I am converting from grams to kilograms, I am multiply by 10 raised to minus 3. Since I am converting from centimeter to meter, I will multiply by 10 raised to minus 2. Since it is cube, this will be cube. This will give you density will be so many kgs per meter cube. Right? Now we know that density is equal to mass upon volume. Therefore, I can say mass is equal to density into volume. Density. A drop of water is spherical in shape. Volume of the sphere is 4 by 3 pi r cube. Mass is density 4 by 3 pi. Radius can be written as diameter upon 2, the whole cube. Right? So now I know the mass of water. Since the drop is freely suspended, therefore I can say that upward force is equal to downward force. Right? Upward force is going to be QE, downward force is going to be equal to mg. Therefore I can say Q, E can be written as V upon D. Electric field is potential difference per unit distance is equal to mg. They have asked you to find out, calculate the potential difference. V is equal to mg d upon q. Right? Mass you already found out before. G you know, distance you know. You should be able to get this answer. The answer for this sum should be 0.2887 volts. Right? Let's see the last sum for the day. In Millikan's experiment, a drop of diameter 10 to the power of minus 4 centimeters. A drop of diameter 10 to the power of minus 4 centimeters has a density of 0.9 grams per centimeter cube. Has a density of 0.9 grams per centimeter cube. If the plates are 2 centimeters apart, and a potential difference of 72 volts is applied, find the charge on the drop. Find the charge on the drop. Now I can say density is equal to mass upon volume. Therefore mass is equal to density into volume. Mass is density. Droplet is in the form of a sphere. Volume of the sphere is 4 by 3 pi r cube. But radius is nothing but 4 by 3 pi r. Radius is nothing but diameter upon 2, the whole cube. This will give you the mass of the droplet. Now since the drop is freely suspended, therefore I can say that upward force should be equal to the downward force. So in which case upward force is provided by the charge on the electron and the strength of the magnetic field. Downward force is mg. They have asked you to find out the charge. Charge is mg upon E, but m is rho 4 by 3 pi diameter upon 2 the whole cube into g. upon strength of the electric field. Now strength of the electric field is again not given to you, which is nothing but V upon D, right? So substitute your values, you should get this answer. The answer for this should be 12.83 into 10 raised to minus 19 coulombs, right? We'll stop this here for the day. Thank you very much.